So again, if your question is this on the quiz tomorrow? No, it's not on the quiz tomorrow, okay? We're learning something new today. It is not covered on the quiz. We're doing 2 days on this. Tomorrow you'll start to see why we need to do this, because this process that we're doing today really complicates the process of taking a derivative when you have to fully simplify. It makes it quite a bit more difficult, okay? Or like it's a lot more work. But when we're doing things with derivatives, we have to have the simplified version. Like we just have to. It's the only way that we can do with them what we want to do with them, okay? In this unit, we look at some harder ones, but generally moving forward in the next unit, the ones that you are going to have to simplify like this are actually going to be easier than the ones we're practicing with now. So if you can do the ones that we do now, you should be good for most of what's coming up. Trig becomes a little bit different, and logarithms becomes a little bit different just because those are different types of functions. But generally speaking, you'll have the idea down. The first thing you have to know with what simplify fully means, like this isn't a technical term, but for us, what it means is fully factored. Technically, I think, yes, that includes common factors. So if there's a common factor and any brackets left or anything like that, you really should factor it out. That's mostly because it's going to make the next part easier. But technically speaking, fully factored would include common factors. Okay? And then the other thing it means is one single fraction. And that fraction must be fully reduced, which is sort of part of the process of factoring it, but it should be reduced. So any common factors that are in the top or the bottom would come out, and they might divide with each other or something, right? So all of that process should happen. That's what it means for something to be fully simplified. Okay? All right, let's get started and see what this looks like. So you got to know, that's what you have to know. You have to know when we say fully simplified, it means one fraction altogether, and it means fully factored and reduced. Okay, so y prime equals. So we're just using product rule and power of a function rule here to take the derivative of this. One thing you might notice, you may have already noticed, is when I bring this 5 down, then when I take the derivative of what's inside, it's just a 2. You could put 10. Like you don't have to show me 5 and the 2. But what we start to do as we get good at this is we start to sort of like do it in a more efficient way. And I know it's just going to be a 2, so I'm putting them together. Really, if I was doing this for myself, I would also have multiplied them together in my head and just started with a 10. You know what I mean? Again, that's efficiency. It's less writing. You're less likely to miss a monomial in the middle of the line, that kind of thing. Okay, and so again, I'm bringing down the 4, and the derivative of what's inside is going to be a 3. So I could just turn that into a 12, but I'll leave it like that for now. And if I had done that all together in the first step, I would have saved myself a full step of writing, because before I continue, I probably want to have it cleaned up to that point. If you're really good at factoring, you might not need to write this out. You might be able to do it in your head, but then that's maybe being a bit dangerous or careless or whatever, so be careful. This is what your answer would look like if it was on the quiz, if we were just doing one line. I've got two things here, one thing and two things. What do they have in common? Abraham? Each of these things, if we think of it as each of them as terms, they each have a bracket, a factor of 2x plus 1. This one's got 4 of them, this one's got 5 of them. So if this was 10x to the 4th, y to the 4th, plus 12 y to the 3rd, x to the 5th, you could common factor this. Back in grade 9, it'd be 2x to the 4th, y to the 3rd. So it's the same process with fully simplifying derivatives. I common factor the 10 and the 12, and if it was a monomial, had an x in it or something like that, you'd common factor that out. But in this case, it's just 2. I can do 4 of this first bracket because I've got 4 in the first part and 5 in the second part. So the maximum I can take out is 4. I want to take out as many as I can. And I can take out 3 of the second bracket because the second part only has 3. 3. I said 3 and wrote 4. Thank you. Okay. I'm going to use big square brackets to keep everything nice and clear and organized. Because now I have to write out what's left. So 10 divided by 2 is 5. For this first part, I took out all the 2x plus 1s. So it's gone. Right? You okay? I took out all the 2x plus 1s, so that's gone. But I had 4 3x plus 2s. I only took out 3, so I've got a 3x plus 2 left. Plus. 12 divided by 2 is 6. All the 3x plus 2s are gone. I've got 1 2x plus 1 left. And that's kind of what always happens. Okay? Because of the way you take the derivative, after you've done this a few times, if you think about it, when I take the derivative, I reduce the exponent by 1, so one of them will always have 1 fewer than the other, right? And they kind of flip-flop. Now I have to clean this one up. (27x to the 6 and plus 16, sorry. And that's what we mean by fully factored or fully simplified. This one doesn't have fractions, but it's fully reduced, fully factored everywhere. What do you think? And this last part in the square brackets has to get simplified as well every time. Ready for another? So this is a square root question, but it's got the square root part already written in exponential form. So first thing we're going to do is just take the derivative. The first one doesn't have an exponent, so its derivative is just 2x times x squared plus 2 to the 1/2 plus, so I'm bringing the exponent out, 1/2 times the bracket subtracting 1 from the exponent to the negative 1/2, times the derivative of what's inside. I could have done that first, and I think as you get more proficient, that's a good idea. Times the first part. Ibrahim.
Just make that x.
We can, can't we? When a half gets multiplied by 2, those are going to simplify. Do you mean like and not even show them in your work?
Yeah.
Yeah. So same thing as like if you notice that you can multiply 2 things together to get 10, you can go straight to that step. If you notice that they're going to simplify, sure. Okay, now because I have sort of, I've done it in 2 colors to show where my derivatives are and everything. I'm going to rewrite this to clean it up. So this is 2x root x squared plus 2. You don't have to write it as in radical form, but often we do. Plus, but Ibrahim, if you do that, don't forget the x, right? I could see people forgetting the x. Kind of looks like it's already fully factored, doesn't it? Does it to you? Is everybody okay with this so far?
On the equation, you don't have to do square roots, right?
No. You don't ever have to, but some people might see it better as exponents. Some people might see it better as roots. We often turn these back into roots at this stage because what we're going to do next, it's going to be helpful. This might look fully factored, but it's not in one fraction. You can't have a sum of 2 things. Okay, simplified fully means 1 fraction. How do I turn 2 things into 1 thing?
You multiply that one by the denominator.
Get a common denominator. So I'm multiplying the first one by root x squared plus 2 over root x squared plus 2. Watch carefully. What happens when I multiply the top, the left part, that first part, by square root of x squared plus 2?
Does the root go away into the bracket?
They're the same root, right? It's like root x squared plus 2 times itself, which is root x squared plus 2 squared, which means this becomes 2x bracket x squared plus 2 plus x bracket x squared plus 4 over root x squared plus 2. Now, if this looks fully factored to you, that's ridiculous because the top has a sum and that's not fully factored. So now we have to expand and simplify on top and see if it will actually factor. What did I get 4? And I've got a common factor of x that I can pull out. And that's fully simplified. It's funny, that's what I thought it was too, but 2 plus 1 is 3. I don't know why we both got 4. I had a 4 in my head or something like that because I wrote down 4 too, but I fixed it. Now, this looks more simplified than what we had in the first step. Like that looks like a mess compared to this. This looks nice, right? So you can see why this works. It doesn't always simplify that nicely. Like sometimes you still kind of have big, strange looking expressions, but usually it looks a lot tighter. And again, it has to be in this form for what we're doing with them, which we're going to start to talk about a little bit tomorrow and then see a lot more of in the next unit. One thing I will advise you is, like, this isn't easy. When somebody else is walking you through it, it looks easy. This isn't easy. It requires practice. And with practice, you'll start to see patterns. in what happens. And there's things that always happen the same way. And once you start to see those and you're expecting them, okay, that's when you're kind of going to be off to a good start or starting to be more prepped for this whole thing, because that's when you can expect how a question is supposed to work out. It makes it easier, you'll be more efficient, and you'll catch mistakes more easily, that kind of thing. So quotient rule. First step is just take the derivative. Whoops. So derivative of the top, you see it there in green, times the bottom, minus derivative of the bottom. All over the bottom squared. So 2x plus 6 to the 6. Okay, clean this up a little bit. Okay, what can I factor? So I got a negative. You don't have to factor out the negative, but I'm going to. 8 and 6, I've got 2. The 1 minus x squared, I've got 3 of them and 4 of them, so I can factor out 3 of them. And the 2x plus 6, I've got 3 of them and 2 of them, so I can factor out 2 of them. See what I was talking about? That kind of always happens. What's left? 4x times 2x plus 6 plus, careful because we got the negative. Easy mistake to make. 3, and we have one of these left. What do you notice? Anything? Yep. Some of them, right? Not all of them. These two, because now that it's multiplied, I'm not adding anything. These two are going to cancel with 2 of those. So that's gone, and I'm left with 4. Now I'm just going to tell you this straight up. The way derivatives work, if the exponent was a 3, when you take the derivative, it should be a 4 in the end when you've simplified. Like, you know how when you subtract 1 from the exponent? So we're doing the same thing. And this is a negative 3 because it's in the denominator. So subtracting 1 from it would make negative 4. So this should be increasing by 1 every time you take the derivative. So if this didn't happen and I didn't have 2x plus 6 to the 4, I would be like, oh, there's a mistake here. Okay, so that's a place that you can check your work, catch your mistakes. Okay, so I'm going to tidy this up a little bit. Now I want you to watch what I'm doing with the bottom. So put your pencil down for a second and watch. I'm factoring this inside big brackets like that. And there's a reason, because I want to show you how this works. This is another common mistake people make. People just factor the 2 out like that. And this is wrong. So you could do this in one step if you understand it, but I'm going to show you why this is true by showing a few steps. Okay, I'm going to continue to tidy up the top. So that should be 5x squared plus 24x plus 3. So this is 2 to the 4th times x plus 3 to the 4th. That's what people miss. The exponent goes on both. I mean, think about it. When I had 2x plus 6 all to the 4th, the 2 that's in there is to the 4th, right? It's not something that you've done a lot, probably. Maybe never. I don't know when else it comes up in high school math, unless it's just kind of forced in by a teacher in a particular question. It doesn't come up very often naturally. I don't remember it coming up in MHF at all. So just watch for it. It's a small thing, but it could, cost you a mark. And then look at this. My 2's are going to cancel a little bit. So this is 2 to the 4th and 2 to the 1. So I'm going to get a 2 to the 3 or 8 on the bottom. So I get negative 1 minus x squared cubed times 5x squared plus 24 plus 3 all over 8 times x plus 3 to the 4th. And we're done. No, we're not done. What about that quadratic? They factor. Except I don't think this one does. But don't forget to check it. Right? If that factored, you would have to factor it. There's so many places where you can miss things. B squared minus 4 times A times C. 516. Got solutions not factorable. I'm done. Is that okay? Yep. Oh, question? No? Just wait a second. Yep. So those are the main types. Like we saw one with a square root in it. They work out one way where you got to get a common denominator. We saw ones with just the product of rule and power of a function rule and how those factor. And then the quotient rule, how it factors and reduces and had some interesting other sort of reducing along the way. Yep. Yeah, I am. Thanks. Okay, we're going to do one more. So if you got a question like this, you might try this. Rewrite it in exponential form. Bring the exponent out front. Rewrite the inside the same way. Subtract 1 from the exponent. Then multiply by the derivative of what's inside, which would be quotient rule. I think this is a bad idea. Because trying to clean this up, if you have to simplify fully, I think is going to be a bit of a disaster. Because this right here is a negative square root in the denominator, right? And then you're going to have another denominator when you do the rest of it. And I don't know how that's going to clean up. So what's the better idea?
Could you do the first step that you already did and then split it into half?
What do you mean?
And then
Not quite, but I mean, you're kind of close.
Put a square root over the numerator and the denominator in the bracket.
Yeah, exactly. So this is a property that we can take advantage of. Okay? Square root of a over b is equal to the square root of a over the square root of b. Square root of a minus b is not equal to square root of a minus the square root of b. All these little properties that come up and people try to use them, make up their own things or do things wrong, you got to know every single one of them in a course like this and when you can use them and how. Okay, so you can go ahead and try this one on your own if you like. Oh, that's going to get in my way. Okay, so I factored out a 2 to cancel with the half. That just happened to work out. Okay. And then obviously I've got the rest of the derivative and the rest of this. And then I've written it back into radical form and brought the other radical to the denominator. Same thing on the other side, but this time the half didn't cancel, so the 2 is still down there. Don't leave a 1/2 as a coefficient on top in a fraction. We don't keep fractions in fractions. Okay, and brought the radical that's a negative down. And all of this is over x cubed minus 5. So just to sort of save space on my page, I'm putting it in brackets and writing times 1 over. And you've seen that kind of thing before. Okay, but don't lose that part of it. It's still part of it. And now we got to turn this whole thing into one fraction. Yikes. So I'm going to multiply the left one by 2 root x cubed minus 5 over 2 root x cubed minus 5. And I'm going to multiply the right one by root x squared minus 4 over root x squared minus 4x to get a common denominator. And I made a mistake already. 2x minus 2. So I got to expand the simplify the top, and now I can move it all into one fraction, can't I? Because I've got a fraction times a fraction, so the bottoms join together. Could you do what? This with that? Nice idea, but no, because of the subtraction. If it was common between both, then yes, of course. It's not common, and I'm adding still in this part, so no. Why did I write these back into exponential form? Amnya, how do I do that? Yep, you can do it. Nasir? Cancel the 2's? What did you say, sorry? Yeah. There. Yeah, I was missing a bracket. Is that what you're saying? Yeah, I don't need that one then. Yeah, thank you. Okay. Not what we're talking about, but yes, good. That would have caused a problem. These are the same thing, so I can add their exponents. I'm multiplying, so I can add their exponents. Oh, I'm getting some overwhelmed looks here. People feeling overwhelmed? This is a hard one. We're not going to do too many like this. Okay. Let's get it finished up. 2x to the 4th minus 10x. I should have done this in order. Minus 4x cubed minus 3x to the 4th plus 12x cubed. Okay. Over 2x cubed minus 5 to the 3 halves. 1 half plus 1 is 3 halves. This is x cubed minus 5 to the 1. This is x cubed minus 5 to the half. So I can simplify them. I'm going to factor this. Yes?
If you go obviously expanding, why would you multiply the number 2 with 1? Yeah.
Where am I looking at?
When you expand.
Oh, I missed a... Ah. Is that right?
Yeah.
Yeah, could be. Practice. Okay, negative x to the fourth.
Once you have to expand it 2 into the 10.
Oh, I need the 20 on this one, yeah. Okay, that's good. Negative 4 plus 12 is plus 8x cubed. Do I have any x squared terms? I do not. I have one x term. And I think the bottom is finished. I'm going to leave it like this. Not going to write it back into radical form. What if that top degree 4 was factorable? I wouldn't give you a question like that. Any questions?